Hey everybody, I'm out in the woods again today. Today we're going to go over a method of how to determine distance and then direction while you're out in the woods. This can be helpful in being able to navigate if you don't have a map, even if you do have a map. These are going to be important lessons to learn. So stick with me and I'll show you what I got going on. You're standing right here. You want to know the distance between a point right here. We'll say, just for the sake of an argument, that that is due north. So what you need to know is you need to know this distance right here. We're going to call this distance A. So all you need to do to figure that out is draw a couple of triangles. This is where the word triangulate comes from. They've got to be right triangles, so take a 90-degree turn and head 270, or due west, for a measurable amount of distance that's divisible by 2. Let's say that's 60 paces. So you're going to go 60 paces this way and stop. Then you're going to put a stick or something in the ground, something that stands up about eye level, so you can see that point from a distance. Then you're going to keep walking in the same direction half of this distance. So if this was 60, you're going to go 30 more. 10, 20, 30, stop here. Make another 90-degree turn and head south. Head south for as long as it takes until you can see the distant object and your stick in your line of sight. It should be right around here. So let's line those up. This is your distant point. This is your stick, or whatever you put in the ground. That means you should stop right here. I was close. Now here's the thing. If we connect these two and make them triangles, that means that their ratios are equal. So this distance will be half of this distance, because this distance is half of this distance. And that means this distance will be half of distance A. So all you need to do is pace it out. We'll use it by centimeters. This distance is 1, 2, 3, 4, 5 centimeters. So that means A should equal 10 centimeters. Let's find out if that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent. So, let's say you need to judge the distance between where you are and a distant object that maybe you can't get to. Maybe there's a river in front of you or a canyon. This is how to triangulate your position to figure out exactly how far that thing is away. So why is this important? Well, let's say you're standing right here and you need to call for help, but you don't know how to tell your help how to find you. Using this method, you can figure out where you are in relation to another known point. Let's say that's a radio tower, or a mountaintop, or a waterfall. By using this triangulation method, you can say, all right, if I'm standing right here, that means I'm 10 units, whether it be miles or meters or whatever. I'm 10 miles south of that radio tower. Due south, please come help me. A member of our party is hurt and we need an airlift out of here. Or I'm lost and I can't find out where I am, but I know I'm 100 meters south of this known point. Can somebody walk me out? This is, of course, assuming you have some kind of cell phone or maybe radio communication. Or maybe let's say you need to know how far it is from here to here because you need to cross a river or a canyon and you need to make a one-rope bridge, like I showed in a previous video. This distance will tell you how much rope you're gonna need. So what if you don't know what direction this is and you're trying to call for help? Maybe that's north, but what if you're wrong? How can you find out? Well, one way is you can look at your compass. Whenever you're out in the woods or navigating in any way, you should always have a compass. Minimum basic equipment. Well, let's say you lost it, or forgot it, or it's broken. So, compass is out. It's not gonna work. How else can you tell what direction you're facing? I'll show you a couple of ways you can work it out. First of all, you can use any electronics you might have at your disposal. A cell phone, a tablet, something with an app that might show you where you are. Now, I live in North America, so all the methods that I use are gonna be Northern Hemisphere dependent. That means if you live in the Southern Hemisphere, these may not work for you. So I live in the northern part of the lower half of Michigan. So whenever I'm navigating, I know that Lake Michigan is always gonna be to my west. If I don't know which way is north, but I know I'm near the lake shore, all I gotta do is calm down for a second and listen. I can probably hear the waves, and I'll know that whatever direction that sound is coming from is west. Your electronics may even have a compass with them that will tell you, within a certain degree of error, which way is north. The good ones will usually rotate the right way and generally tell you always which way is north, which would be 360 degrees or 0. If you're navigating in this area, in a generally wooded zone, without a bunch of cross streets and easy landmarks, but you know there's a highway directly south of you, then hold still for a minute and listen. See if you can hear cars, or better yet, trucks or motorcycles have saved more than one life because they're so loud. Listen for the traffic, and you'll know that that's a general southerly direction from where you are. If you happen to be in a populated area, or an area that has some urban features like satellite dishes, just remember those dishes need to point in a general southerly direction to pick up the satellite signal. So the dishes will point generally south. You can navigate that way as well. Pay attention to what time of day it is. If it's morning, the sun will generally be in an easterly direction from where you are. During midday, if you're facing the sun, then you are generally facing in a southerly direction. In the evening hours, at the end of the day, the sun should be west of your location. Navigating at night is not hard, but you need to know your stars. The first constellation you're going to look for is called the Big Dipper. This looks like a ladle or a cup with a handle on it. Use the outer two stars of the cup and follow a pathway upwards to find Polaris, which is the North Star. This is the only star in the Northern Hemisphere that will not appear to move as time goes by. This way, after a few hours have elapsed, it looks like the Big Dipper has moved. But if you use your same two stars and follow a pathway upwards, you'll find Polaris again, and you'll realize that it has not moved at all. This means that wherever you are in the Northern Hemisphere, Polaris will be due north. Once you know your first cardinal direction, you can find your other cardinal directions as well and navigate that way. You can also use the moon to navigate if you can't find the stars. Draw a line between the 2 points of a crescent moon, and where that imaginary line intersects with the horizon, that will be a southern point. Also remember that the moon follows the same path as the sun, rising in the east and setting in the west. Okay, folks, so that's determining distance and determining direction. I hope you learned something. I hope you can find this information useful, and I hope you liked it. If you do, please remember to give me a like and a share and a subscribe, and I'll see you for the next one. Thanks.